Welcome to Pipeline Conversations, a machine learning podcast by ZenML. I'll be having some conversations with the people behind the tools that ZenML offers as integrations. We spoke with Ben Wilson a few weeks back, and today I'm pleased to publish this conversation with Emeli Dral, co-founder and CTO of Evidently, an open source tool tackling the problem of monitoring of models and data for machine learning. We discussed the challenges around building a tool that is both straightforward to use while also customizable and powerful. We also got into the thinking behind how they grew their community and blog along the way. As always, please let us know if you have guests you'd like me to speak to by sending a message to us on Slack or by emailing podcast@zenml.io.
So, my name is Emeli. I'm co-founder and CTO at Evidently, where we build open source tool to monitor, analyze, and validate machine learning models in production. I believe that's an important point. Actually, I came from the computer science industry. I graduated from the applied mathematics and programming faculty, and since that, I just got the first internship in online search engine company, and since that moment, I worked in IT. Started as the general software engineer. I wrote in C++, then switched to Python, and actually at the very beginning, I really didn't like the language because no typing, no things like this. You can do nothing with the memory yourself, so a lot of things. And I was like, oh my god, who actually will ever write something in production in Python? But apparently, now myself use it in production. So just funny thing. And then after being a software engineer for a year, I learned something about machine learning because in Yandex back then, it's a search engine company. There is the ranking formula, which helps to find the relevant pages for user queries. They used machine learning, and I was so fascinated by the technology. So I started to learn things. And after a couple of years, the company decided to share the expertise and start providing these services to other companies. And I kind of volunteered to try it. And there I learned a lot of things about the using machine learning in production, especially for more classical non-IT domain areas. And it was a lot of fun. So I believe that particular part of my life inspired me to work on Evidently because I figured out that actually building machine learning model itself and even building a service on top of it is something that you pretty much can do with the existing tools and expertise. But when it comes to really supporting this model for a long time, there are a lot of different things that happens. And I felt, at least at that time, that there is kind of a lack of nice tools that can help you to do it in a very straightforward way.
Yeah, I guess if you have a maths and computer science background, at some point you hit machine learning. That's
Yeah, that's true.
So yeah, tell me a little bit about the backstory behind Evidently, like where you came up with that, where that came from, and yeah, what it does.
Yeah, sure. That's interesting. But we met with Elena many years ago. Now I believe we know each other for around 10 years. So really, that's a really long story. So we met back then where we had to deploy machine learning based service in manufacturing company. And it was pretty complicated task for us because, well, there are a lot of new information systems that we never seen before working in IT companies. So manufacturing is really another world. And we faced a lot of different challenges, starting from how you gather this data from the sensors, how do you process it, how you spin up a service in the closed perimeter, and things like this. We really understood that we have very nice fits to each other, so we liked to learn things, to solve issues, and we succeed with that project. So we finally built that service, which helped to decrease the usage of raw materials and optimize that. And the figured out that like at the very beginning, when we just deployed the service, it worked pretty fine, and there were no issues with that. But like several weeks later, we had to intervene and update the model. And actually, it was not easy at all because we had to query data to like manually load it, connect different pieces of data to each other, and it was a lot of manual work actually. And we figured out that really this is the common issue, common problem for many companies, especially who operate in more uh, like let's say older industries where they don't really work a lot with the data and where the main process is more physical, let's say, or offline. And we decided that well, probably there are a lot of things that can be automated, and we both had an interest in building products and in open source because it's very nice feeling when you create something and can like publicly share it with the audience and get some feedback and share opinions. So we just figure out that we like it, and we decided firstly just try to like build something and see how it will goes, and later it brings us to Evidently.
Mhm. It's funny that you have kind of roots in kind of manufacturing optimization
Yeah,
and so on, because that's also where ZenML comes from as well, somehow in
cool,
its whole
cool.
background as well. Yeah, it's funny.
Very nice.
So yeah, so I mean, ZenML integrates with Evidently, and we've seen like a ton of people using it in their pipelines as a way of monitoring their data, monitoring their models, and so on. Like, what are the key problems that people have? Once they've trained their models, let's say that Evidently helps them with.
I believe generally it can be fair to say that um, machine learning models and building machine learning models is pretty complicated task just because you never had really a deterministic input. I mean, not like input format, but you cannot really set the narrow limitations or narrow expectations for each individual feature, and that's it. So you should be ready that you can get as an input like everything, right?
Mhm.
And this is why you should build something robust. But from other point of view, you cannot really spend a lot of time for checking because a model is pretty generally machine learning models has pretty mm, computationally complicated algorithms, and it already takes a lot of time. So you should to find the balance. And I believe generally people have a lot of problem with the um, learning serving skill when you train your model on the fixed data set, and you pretty much like how it performs. But later when you move it to production, you will start getting a lot of things starting from data processing issues like I don't know, broken sensor in manufacturing, or some errors in pipelines, to things like data drift or target drift, and it's really like hard to keep an eye on everything. This is why I believe having tools which helps you to observe what is happening without needs to have a like huge expertise in statistics, visualization, and engineering can really help a lot with that.
Yeah, I mean, you definitely. I think you're definitely correct that it's a very complicated thing to do, and but like there's a mix in terms of how the tools approach it. Like some tools try to completely take away all of the complexity from the user, and then it's kind of like magic. But then you also have the fact that the complexity exists, and there is some real like stuff around statistics and so on going on as well. So given that you're a tool which like helps people understand or explain some of the things in between these two areas, like how do you balance creating a tool which is like super complicated and like 1,000 like, yeah, just like something which only someone with a math PhD can use versus people who only know the magic part of machine learning?
You really hit a sore point with this question because we naturally ask ourselves every time whether we are more a tool that helps you to build everything from a small modules, or we a tool with the very nice defaults which helps you to like easily spin up whatever you want. In our case, reports, and just work with this. We're trying to design our APIs in that way that users can easily get the final results like out of the box. So for now, it's like a couple of commands where you just specify what you want. It can be either a profile to log your data somewhere, database, for example, or visual report to observe it in browser. And now we are working on test suites. It's something closer um, uh, to the things that you use for checking some metrics and tests on top of your data. So this can be done easily, like in 3 or 4 commands in Python. And I believe when you just starting to work with your machine learning models, or if you have like something that you use in a batch mode, like a couple of times a week or maybe in months, then it shouldn't be more complex than that, because it's to me a bit questionable when you have to spend more resources on setting up the monitoring service compared to the building the machine learning based service itself. So this is why we're trying to like keep at least this API pretty simple. But from other point of view, I deeply feel maybe that's because I'm biased to manufacturing a bit, but in many spheres and for many problem statements, you cannot really get something that can be described as one size fits all, because like you always need to customize something. Sometimes you want to use another statistical test. Sometimes you want to measure drift without any statistical tests, just because you want to keep another approach, right? And this is why we try to optimize all the interfaces, even on the intermediate levels, because we know that there are some users who prefer to take some smaller modules of Evidently and use them directly. For example, I was pretty surprised when one user came to our GitHub and created an issue where he mentioned that we changed some low-level API and it wasn't on the release notes. And I was so surprised, like, how do you even like notice that? And he said actually that he was interested in using analyzers purely, and this is something that we actually happy about, and trying to make sure that we do not have really very complicated interfaces which users cannot use. So we try to still have it like a toolbox, but with the very simple high-level interface. Probably this will work, but who knows? I know that a lot of companies and products like end up with this trying to fit for all scenarios, but we try to like maybe somehow solve it.
Mm-hmm. Mm-hmm. And how much, how much of this is nothing to do with what you write in your code base? Because I mean, I know you you spend a lot of time and you have like great blogs and educational material, which I definitely would recommend people check out. But it's almost like you need to like educate your user base at the same time as you're building the tool as well, so that you don't give people, I don't know, a false sense of security, or that it really is like too easy. Like, yeah, like how do you balance that in your heads?
For me, it's super hard because I feel myself more like an engineer, and sometimes when I like invest a lot of time in creating examples or writing a blogs, I feel like I'm doing something wrong, and I need like to come back to my engineering stuff and writing more code. But my co-founder Elena really inspires me to do that. She shows me that people really benefit from it, and this helps a lot to like find this space in head to do it. And actually, personally, I like to connect with people and see how they use the tool, what causes the problems, and what issues they have with their machine learning services. And we understand that you cannot just like write a great tool and leave it in open source. with this I don't know, with the idea that someone will just find it and use it in a proper way. So we believe that when you build the observability tool, it's important to share how exactly it works and share something around the use cases, because you can exchange the opinion, and people really sometimes, I'll better say often, share very nice ideas and like great designs on how evidently can be used in different pipelines. So what we do with the team, we all answer the issues. We have a pretty nice Discord channel where literally everyone answering the questions and take part in the conversations. I wish I could do this more, but now before releases, really everybody have their heads down and write the code. But I don't advise anyone to underestimate the importance of building the community, because at the end of the day, when you have a lot of work and you really, I don't know, feel a bit mm, fatigue out of it, this is something that can inspire you to move on and continue your work.
How does that work in? Because obviously you mentioned like Evidently is an open source tool. How has that been like both like working on the tool in the open source space, like interacting with other people in other tools or other community members and so on, and like what are the advantages or benefits that you've seen from that approach?
Oh, that's very interesting, because it's my first open source project, and same for all the other team members. We have never had this experience of working in open source. So at the very beginning, we made like a lot of mistakes actually, and now we're trying to like cover all of it. And I believe the first learning. Hmm?
Why did you choose open source to start with then, if none of you came from that background?
Just because we really used a lot of open source tools, and we wanted to like give back to the community. So we felt like there is something we can share, and we wanted to do it. And honestly, we tried to look for open source monitoring solutions. Now there are quite a lot of them, but back then there were nothing else, and we decided that it makes a lot of sense.
So I
Mhm.
interrupted while you were talking about like the benefits there. Yeah.
Yeah, so benefits and learnings, that's the topic I really like, because I had really unrealistic expectations about working in open source. And I felt like users really understand that it's just a new version, and it can have a lot of bugs and problems. But when someone sees some library like available in Pipey, users have pretty high expectations on how it should work. So this is something we still trying to like cover, because we need to fix a lot of things with the documentation, public API, and so on. But still, there are a lot of benefits, because first, you cannot like create the unrealistic picture for yourself and like live with believing in this picture, because it's really fast how you get this feedback. And if no one using your tool, if no one downloaded from Pipey, you just cannot continue lie to yourself that you're doing something right. So this is the thing I especially like about it. Yeah, another probably is the contributors, because when someone spends and invests their time into helping you to fix your tool, you really feel something like a magic happening, really, because I like, wow, this person who had a lot of experience, a lot of job, and so few times decided continuously to come and help me with my job. Wow, that's nice. So this is something I really love about open source. And the users, of course, because when you have to like buy a tool before you use it, this is, I believe, a pretty big breach to cover. But when it's open source, it's much easier to just come and try and make some opinion about your tool. And I think it's like it's kind of a trend of I don't know these days, right? So if you have something to share, why not to share? And I really want to support this trend.
Mm-hmm. And I mean, it's so you're working in this space where increasingly there are more tools. It feels like, well, not every day, but quite often there are new kind of monitoring tools come out. How like mature do you find this space? Like, do you think that like we know what most of the big abstractions are for monitoring and we just need to like implement it in a nice way now, or do you think we're still discovering like the boundaries of what this space looks like?
I believe there are a lot of things to discover yet, just because the monitoring is the very well formed concept for software engineering. If you like do monitoring for some software service without any machine learning things, you literally like know what to do, right? So there are a lot of standard tools you can use. So you can use sometimes serious databases, right, to store your metrics. You know what to calculate, some latency, CPU usage, memory usage, things like this. And you probably know how to set up an alarms, who should do what when something fails, and this is pretty standardized thing. And what I can see from the community and from people who are trying to like solve their monitoring tasks, they're trying to take these well-known architectures, which are very good for standard, let's say standard services. Actually, there are no standards because there are a variety of things, but let me say just non-ML services, and apply this architecture to machine learning things. And I believe it's very logical, but there are still a lot of things that should be adapted for machine learning. What I can see a lot from the community that people trying to over complicate things and create a very complicated monitoring solution for machine learning models, even in situation where there is no need for that. I really was super surprised when I saw that people tend to monitor their batch models with help of calculating like literally hundreds of metrics and using the primitives to store it and update the RMSE or log loss like every 10 milliseconds, where you're like, actually, why you get these constant plots, right? And put it in Grafana. And I believe it might happen just because when you try to Google monitoring for a software service, you get tons of content which describes you how you can set up this online monitoring with a lot of tools and pretty complicated scenarios. But I believe it's very important, especially when you have new machine learning based service, to really sit and think about what really can happen and how you're going to react on this. So what you really should do or who should do what, and only taking this information at hand, design your monitoring. This easily can be just batch checks that you calculate every time you call your model in batch, and this can be more than enough. Or, of course, if you have like online serving model operated in the high load, then of course it makes sense to have a lot of things with time series databases and visualization tools with alarms. So I believe there is no standards yet, but there are a lot of things that can be created here.
Mhm. So it's a mix of um I guess you're saying like it's you need to understand your specific use case and whatever is going on for your specific data or however you construct your system, and then depending on that, check in with your data and your models and the performance and the behavior whenever is appropriate.
Yeah, I agree there. And it's super interesting that sometimes when you try to like figure out what is the specifics of your use case and what can happen, you really can figure out that there are not actually a lot of things that you want to add to service health monitor. This really happens, especially if you have your machine learning model just to like do some fun stuff, but no, like nothing you really care about. And vice versa, of course, also happens. Sometimes you really want, for example, to catch your outliers even before you applied your machine learning model and decide whether you're ready to apply your model to these objects, or you prefer to like use some rule-based systems, or even send these objects to manual review or something like this. So it's really vary. And sometimes I feel like people try to maybe optimize their time on deciding what actions can be taken after you get this or that failures, and just trying to use some standard approaches. And sometimes they can either get a lot of false alarms, like if you have thousands of features and every day they are drifting, but you really don't do anything with this information and you just send them this alert, or vice versa, when you like just use the service health monitoring for your machine learning model and it really does pretty sensitive job, you can easily miss something. So I always suggest to start from the use case and the actions that can be taken on if something goes wrong.
Mhm. Have you seen any really like weird uses of, or like a very unexpected uses of Evidently along the way?
I couldn't call it weird, but unexpected, definitely. So, at the very beginning, when we just created the public release of Evidently, we saw that there are some users, probably from consulting industries, who tried to use Evidently to automate their um, customer report preparation or something like this, and they asked to like whether it's possible to customize the color schema and add some specific brandings. And we're like,
Oh, so like a
it's
data visualization tool or something.
yeah, yeah. And we're like, oh, we didn't really think about Evidently as as of a BI thing, right? So we were pretty surprised, but now it's kind of possible with
Mhm,
your help,
mhm,
actually. So thank you for adding these color schemas. That's very important thing for our users apparently, and it makes a lot of sense actually.
mhm.
And another interesting approach was when we just released the API where you can take the reference dataset and current dataset. So you could perform some comparisons, for example, to estimate the data drift or data quality. So we really expected that users will take the same model and just different batches of the model usage. But users started to like use our tool to compare the models on top of the same data set, but different models, and we were pretty like um, surprised by this behavior. But still, that's possible because well, we calculate a lot of metrics related to models quality. So this definitely does make sense for some comparison. Oh, and I just reminded about the last and probably the most surprising scenario. Actually, that's I believe that's pretty hard to develop tool that will work very nice on top of all different data types. I mean, good for tabular data, pictures, text, and things like this. So we're still thinking about it, but for now, evidently is optimized only for tabular data. And once we got the user who tried to apply evidently for pictures, no, sorry, for text. And what he did, he took the encoder and the vectors he got out of this encoder and calculated data drift on top of these encodings of his texts. And actually, it's technically possible to do, right? And probably if you see the drift, you can uh, at least interpret the drift size. But
Mhm.
really, analyzing the drift of different like components of vector is something new to me.
Right. Yeah, I can maybe contribute my own weird use case somehow. Like, so I've been using it for an image, an object detection problem that I've been working
Wow.
on. So I use it elsewhere in the pipeline, but the super useful thing that I found was using it for synthetic images, which I created to compare, where I create a whole bunch of metadata about the image, not just the width and the height and the kind of the color patterns in the images, but then also the object, like the boxes on top of, like, which are overlaid on top of the image, the number of them, the size, the orientation, proportion of the image. So I create a whole bunch of metadata, and then I separately I do synthetic image creation. So I try to replicate the original images somehow to help with my training. And so I've been using Evidently to kind of get an approximation for like how well I'm doing at creating really good or similar synthetic images. Yeah, that's probably not what you built it for originally.
But this definitely makes more sense to me, because when metadata is the tabular data and you can use it in this way,
Yeah.
I think it makes a lot of sense.
Yeah. So one of the things which I definitely, I think anyone who comes into who joins it and who interacts with all of you in the community, have like found that like the Evidently community and the how you interact with users and so on is like, yeah, it stands out as like a happy exception. Many of these kind of communities are either dead or maybe not so pleasant to be in. I'm kind of curious, like how, I don't think this came about by accident. So like maybe you could talk a little bit about like how you've built that, how you think about kind of growing your community.
Oh, thank you so much. It's so a lot of pleasure to hear it, actually, because it was a goal. And we little bit, I don't know, probably I'll better say it to myself. I'm coming from data science community, and sometimes it's like it was hard to come and ask some questions without like feeling yourself a bit dumb person who didn't did his homework, right, and just decided to come and use someone's time to get these answers. And I really wanted to have a place where anyone can come and just share their thoughts and ask something and share something. So first of all, I wanted to have this atmosphere in our company, because we have now not many team members for now, but still we have two developers, we have community manager, and we have data scientist. And our data scientist, she is writing the code and production code. And sometimes when you have like backend engineers and other team members who write in the code, it's a bit hard to communicate, because you never feel that you good enough in coding, right? And we wanted to have an atmosphere in our company where engineers can ask whatever they want about statistics and machine learning without feeling bad about it. And same for data scientists, analysts, so you can just come and ask how do I implement this function in Python or in TypeScript, or like whether I'm doing something stupid or not, and it's pretty okay. And of course, same for community managers and managers, so whoever can make a call for like 15 minutes, 30 minutes, and just share what they heard or saw on internet and how they should think about it. So we started from ourselves and just somehow share this atmosphere with the team members. And later, when we created community, there were only like at the very beginning few members, and we really tried to treat them as they are our colleagues or friends somehow, and trying to really like solve the problem and make everybody feel good. And this is something we care a lot when we hire people. So we really are trying to somehow feel whether they share this attitude and they really like happy about helping out others and solving the problems. So that's how we started. And now we have something like on goals. So everyone, like literally everyone, answer the questions. I'm holding the community calls, and thank you so much for coming. It's really makes us feel happy when you see it. And we try to continue it this way, and we try to generate a lot of content where we can really share the knowledge and, for example, results of experiments. Like 2 days or yesterday, we published a new blog where we compared different methods to calculate and to detect data drift in machine learning. And we really made a lot of experiments. We wrote the code, so it's not just like something you right for yeah, just for marketing purpose. So maybe we do not create enough content because we spend quite a lot of time for each blog and for each piece of example, but we believe that there are a lot of like marketing in a bad sense content available in the internet, and we try not to like adapt there, but build something that makes sense. And actually, at least for now, it works well for us. And I believe people who read such things, they get an interest and try to like connect and maybe advise something. For us, there is really no problems if someone, for example, get these experiments that we performed with different drift calculation algorithms. So we really got this synthetic data, calculate and share the intuition, and we are completely okay with the fact that someone can take this algorithm and implement it in other tools, or maybe just used it as the raw Python functions. I think it's still very good when you share something with someone and people then started to use it, and maybe later will come and share with you how it really turns out, like maybe months later when they monitored something with help of your algorithms. And this is something we're trying to like continue.
Yeah, I mean, I think probably it feels to me like in the long term, like as more and more tools develop, and maybe like most of the tools do kind of similar things, in the end, like the community and the content that Evidently does is kind of going to be your secret weapon, because it like allows people to use the things, the features, and to like understand what's really going on, which many tools don't invest as much in that. So yeah, I think that's
we do hope so. At least, even if someone will not use Evidently, I believe these information and things they can learn will benefit to the whole machine learning sphere, if we can say so. So more services will be more robust and monitored.
yeah, for sure. What would be, apart from the Evidently blog, do you have good resources or places that people can go to learn about like the challenge of monitoring and the kinds of problems that you help with? Do you have any suggestions?
Yeah, so we're trying to take part in some educational activities and courses, at least like to cover some parts related to data monitoring. And one of our recent activities is MLOps Zoom Camp, which is free and open. And we'll give lectures on monitoring part. So we will share some information about several tools, not only Evidently. There will be some code examples with MongoDB, Prometheus, Grafana, Profit. So we share we share the opinion on different monitoring architecture. So I really like, let's say, I really eager to somehow share the thoughts that even if you have online monitoring machine learning service, you don't really have to always create online monitoring schema for this service. You can still go for batch, especially if you mostly monitor things related to model performance and you don't really want to recalculate quality metrics after you get each new one object. So we created two different monitoring approach, batch one and online one, and just shared it in this course. So that's how we try to somehow interact with the users in different like courses and other places.
So before we move on to the final couple of questions, like what can you tell us something about what's coming up in the roadmap for Evidently, and what are you working on building at the moment?
Oh, sure. I really like this new thing we are working on right now. It is called test suits, and it's strongly connected with the with this thing with batch monitoring, because I really see a lot of cases where users try to build online monitoring solutions where they don't need to, and I'm really think that we should keep it as simple as possible, because when it comes to supporting things and when it comes to maintenance, we really prefer to like simplify things. And what we are trying to build now is creating these test suits, which will be the sets of tests for different potential for different kinds of problems that can happen with machine learning models. So we are working on both a very nice API where you can just, as we like, show your reference data, current data, and select the presets you like. And now we are we make a lot of efforts in creating these presets. So we're trying to make it reasonable and not overwhelm user with the amount of different metrics, just because we know how to calculate it. So just trying to make it reasonable, and we created some presets related to the specific cases. For example, model performance assessment without having a target function, so with this delayed feedback, or a case where you need to assess data quality, right? So we just created this specific use cases and covered it with presets, and we want really see what is a real thing, because probably it will be much easier to just get these presets and apply it to different parts of your pipelines. But still, we have a lot of ways how you can customize that. So it will be very easy to create your own tests and add it to the existing presets. So a lot of work related to batch monitoring, but we do hope that it will help for many users, because I personally saw a lot of batch implementations on models in different industries, starting from manufacturing and to some online marketing campaigns. So in different spheres, and I believe if it will be easy enough, more people will start monitor their models.
Exciting. Look forward to seeing it. So we usually end with a couple of questions, which you can answer however you want. The first one is kind of what would be either a best practice or something, or like a specific, I don't know, test or something that someone could use to make their putting models out into the world like more robust.
Good question. So, well, I think the best you can do is when you build machine learning model, make sure that you share the information about how it performs, not only with the engineering team. This is something that we usually tend to do, but also with all the rest members who somehow interact with the model. And here I mean domain expertise, for example, some process engineers, and some business stakeholders like project managers or business analysts. And they can probably they will prefer to use another dashboards or another reports. But this is something I suggest to invest in, because this will help you to really make sure that model solves its business problem and brings value.
Nice. It's funny. Many of our guests come on and they say, actually, the tech is important, but really, what's more important is like communicating with your team and like, yeah.
Yeah, I agree here.
And what is one kind of piece of putting models into production that you feel hasn't been given enough attention by people who build tools for MLOps?
Very nice question. I think when it comes to building machine learning models, there are really a lot of tools that helps you to optimize the experiments and even deploy a model in production environment. But what is a bit where I can see a bit of luck is how you can actually, let's say, retrain model in automatic way and get this information about how it went. So I think very important, like next step will be to create some tools that will automatically detect the right moment for model retraining. And here I mean both sides of the medal, where you do not retrain your model like on daily basis just because you technically can do that. But you estimate whether you have enough of reasons to retrain it. So if you see new patterns, data drift, for example, or concept drift, together with the estimation of do you have enough new data to actually successfully train this model, then train it and automatically assess the quality And here by quality, I also mean a lot of things related not only to accuracy stuff, I mean not only to quality and error-based metrics, but also for some pretty sensitive industries. It might be things related to fairness, bias, or quality assessment for specific segments. I think there are a lot of jobs that can be optimized there for automatical retraining, and maybe this will make the process of serving machine learning models closer to like standard engineering services, where after deployment the quality of your service do not generally goes down, it somehow stayed the
Right.
same. And yeah, when you fix some bugs, it's just became better and better. But for machine learning, it's just not the case, right? So you always try to like keep it at the same quality level. So I believe these things with automatic retrain might help as well.
So more automation so that we're not just doing this, what we currently do, which is like feels like a very manual process a lot of the time to maintain the performance, like you're saying.
Yeah.
Great. Well, thank you very much for coming on. I encourage everyone to go and check out the blog, to use the tool, to check out the documentation and so on. Like there's lots of things for people to go and look at.
Yeah, thank you so much. I really enjoyed the conversation, and you bring up a lot of very important questions, and I feel like I should think about it later and maybe discuss with colleagues, because yeah, there are a lot of things to like discuss.
Thank you for listening to this latest episode of Pipeline Conversations. If you enjoyed what you heard, please consider giving us a review wherever you get your podcasts. It helps us get seen by more people, and of course, it's always nice to receive feedback. If you have suggestions for future guests, please send them over to podcast@zenml.io. Thanks. Until next time.